Jennifer,
Hey
welcome.
guy, how are you?
Welcome to the Perium YouTube channel.
Uh, Thank you so much for having me on. I appreciate it.
Very welcome. Tell me, where are you physically located right now in the world?
Right, I'm in Boulder, Colorado. I've lived here for like 20 years.
Okay, now where is Boulder, Colorado in America? So I'm just thinking it's sort of on the west coast, up sort of towards near Canada. Is that right?
Nope, it's actually fairly smack in the middle of the United States,
Oh,
almost equidistant from everywhere, and it's at the juncture point where the Great Plains meet the Rocky Mountains. And right where the Great Plains meet the Rocky Mountains and go up into the Continental Divide, it's Boulder, Colorado, in
wow.
Colorado.
Okay, and what's the weather doing there right now?
It's been rather chilly here because we've been stricken with that Arctic finger as the Arctic vortex splits once again, and it gets extremely chilly. As you know, the Arctic's going through its death grasps, and as a consequence, you're getting abnormal and abrupt climate change events happening.
Yeah, okay. All right. Well, I'm in Brisbane, Queensland, Australia, and we've been having heat wave after heat wave and cattle falling down dead and lost 30% of the fruit bats a couple of weeks ago through a heat wave event. And the Murray-Darling Basin, or the Murray-Darling River, sections of it are just turning up dead fish floating everywhere. It's pretty, it's intense, pretty full on.
That's horrible. I have heard, and I even posted on my Facebook page the other day, that you guys have been having the most horrendous heat wave, and 15 hottest places in the world the other day were all in Australia.
Yeah, look, we're all copying it. So, Jennifer, when we last spoke, you told me a story about how you came to develop an interest in issues associated with the Arctic and climate change. Can you repeat that story to me about how you used to fly over Greenland, and just tell
Oh
me
yeah.
how you came to take an interest in Arctic methane issues?
Right. Well, I grew up kind of in an international sort of setting because my dad was in the Foreign Service, and I grew up in both Asia and West Africa, Southeast Asia and West Africa during my childhood. And during that childhood, we took many trips, and some of the trips we took as a child did take us over the North Pole and right smack over Greenland. So I was familiar with Greenland from having just flown over it, from a visual perspective. And my experience as a child of Greenland, even in the summertime when we flew over, it was just a vast, endless expanse of ice, unmelted, just kind of savage and unrelenting. So back in 2012, my sister, who lives in the UK, had gotten tickets to the Olympics. The Olympics were held in Great Britain that year in London. And so we went to the Olympics and we had a fabulous time, and we went to the closing ceremonies, and it was just on cloud nine. It was absolutely amazing. And coming back, I flew direct flight from London Heathrow back to Denver, Colorado. And generally speaking, that direct flight does not take you over Greenland. It takes you possibly over Iceland if the plane is directed in more northerly fashion, but generally speaking, not over Greenland itself. However, as fate would have it, and it was the beginning of September 2012, and those of you who study the Arctic sea ice may remember that in September of 2012, 95% of Greenland experienced melting on the surface, and there were moulins and melted glaciers and rivers and lakes and, on and on and on. Very, very dramatic, pieces of equipment getting washed away, down rivers like tractors and all sorts of things. So anyway, we're coming back in British Airways, and I'm minding my own business, and the captain gets on, he goes, "We have been directed by, air traffic control, whatever, to go a more northerly route. So today's flight will be taking us directly over Greenland." And I was incredibly excited about this prospect. And I was like, oh, good, we're going to be able to fly over Greenland, because I had already been studying climate change quite a bit. And I was very, very much up on the melt that was happening in Greenland, and I wanted to check it out myself. So there's something that happens to a person when they see something for themselves. There's an emotional reaction that sets in. And I think it's all well and good to have intellectual knowledge about, you know, graphs and climate change and data and all the things that are happening. But it's not really until you see it for yourself on some level, either through some abrupt climate change event or some visual, you know, treat. Like this was an amazing thing. So we were flying back and it was a bit socked in with fog and clouds from Great Britain over to Iceland, and I was a bit disappointed because I thought, oh God, this is going to be a complete washout. But lo and behold, about 100 miles or so before we hit the coast of Greenland, it completely cleared, and it was just like poof, all that fog and overcast clouds just kind of went away, and there was a high pressure zone over Greenland, as it would be had. And I looked down into the ocean and I thought, oh, it's very weird. There's like all these white caps and it's all choppy down there. How can it be so rough down there? I didn't really realize what I was looking at because I was seeing it from 36,000 feet or whatever it was that we were flying. No, it wasn't rough. It was that the sea was full of ice. The sea was full of giant icebergs all over the place. And from my perspective, just trying to understand what I was looking at, it was like I thought it was whitecaps, but in fact, it was all icebergs.
Mm.
And then when we got up to Greenland itself, it was an amazing thing. Greenland, the east coast of Greenland, is ringed by really savage mountains that just go straight up. Of course, there's no vegetation and they're very rocky and they're very pointy and jagged. And so the first view I had of Greenland was of this mountain range, just savage mountains just poking straight up. And all around these mountains were these kind of black and white glacier flows, and the black was all the carbon, and it was making these long lines in the glaciers, kind of like, you know, those rip lines. And I was looking, I was like, oh my God, look at this place. It's completely melting down, because there wasn't one place that wasn't melting down. Like every place you saw ice, it was condensed, it was black, it was grotty, it looked sad, it looked unhealthy. I mean, the glaciers were dying. It was very, very clear. And then when we got into the interior of the island itself, I saw how the entire surface of Greenland was covered with lakes, with little rivulets, and with moulins, where like a lake and a river will disappear into the ice sheet itself. And I just watched this for probably, we flew over it, I don't know, it must have taken 45 minutes or so to clear it. It was like in the bottom third of the island itself. And I just watched it, absolutely fascinated. And I like, this place is melting down. This ice is dying. And that was, and it struck me on a very, very emotional level.
Mm.
And I could see that the whole place was just going to go down. And I knew that there was so much ice in Greenland to the tune of, I think, 27 feet of sea level rise is wrapped up in that Greenland ice cap, because the Greenland ice cap can be up to a mile thick. You know, ice plus heat equals water. It's not like rocket science, right?
Yeah.
So this is chemistry. This is simple things that every single person knows this, you know. So, you know, I watched it, and it affected me in a very visceral way, because I was already primed to understand this knowledge and to understand the implications of Greenland melting. So when I came back, I redoubled my efforts, and I just became more and more almost obsessed with climate change information and digesting it and reading the latest articles and really trying to understand what is happening. And it was after my experience over Greenland and my obsession with reading climate change articles and putting all the dots together, I woke up one night after that at 3 a.m. and I said, oh my God. And it all kind of synthesized in my, and I saw the trend lines, and I saw where this was going, and I said, we're going to lose the earth. This is happening. And I didn't know what I meant by, you know, we're going to lose the earth, but I knew that things were never going to be the same again, and that the little window of life of my lifetime was not how humans were going to live in the future.
Mm.
And one of the greatest failings of human beings is the inability to understand the exponential function. And what I mean by that is that from our human experience, you know, I mean, we've evolved, you know, through millions of years. You know, we're like simians. We're not equipped to understand this from an intellectual standpoint. It does not compute. So we think, well, each day is probably going to be like the next day, like the next day. Maybe it'll change a little bit over time, a little bit over time. But the thing is, with the exponential function, is that things will change slowly and then a little bit faster, and then they'll kind of go off the charts.
Yeah.
And that's the way climate change is. And that's the way abrupt climate change is.
Yeah.
So what does that mean? That means if you double something in a glass, you know, let's say you have some bacteria or something in the glass, and you in a Petri dish or something like that, right? And you double it every day. Every day it like has babies, and it doubles in size, and then it doubles in size, and it doubles in size. The day before the Petri dish is full is which day? I mean, the day before the Petri dish is completely full, it has 50%, it's 50% full, and then it doubles again. So you don't see the end is coming until really right before, and it's kind of awful. But that's what climate change is like, and that's kind of what's happening.
Yeah. So I have a frame that I operate, a term that I coined a few years ago called ecophony, which is the portmanteau of ecology or ecological and epiphany, an epiphany being an awakening. Normally it's the term epiphany sort of relates to, you know, revelation of God or something. But if you put a ecological and epiphany together and you get ecophony, this is a frame that I use because a lot of people that I meet who are into environmental stuff have had some particular moment which has helped them wake up. I remember I've had a number of these ecophanies. The first one really was when I was working in the oil industry, standing on the bow of a ship off the coast of Taiwan, watching the plastic bags drift past. And this is back in 1992. And that was something peculiar happened inside my head. Something became real. So that term, that sounds to me like you're in that plane flying over Greenland, and you had that same sort of, you know, emotional, spiritual, or intellectual realization or awakening of something to do with the planet. That's what I'm hearing from you.
Absolutely, that's what happened. And here's the question. You know, everybody had that opportunity when we were flying over Greenland to take a look out of the window and to have that same experience. But nobody else was. All their window shades were shut, and they were watching 110 channels with nothing on it, you know, on the little TV that's right in front of their nose that they give you now. So, I mean, what causes one person to wake up and one person to not wake up? Do you know?
Well, no, and that's actually part of the reason why I asked this question, because I still wonder to this day why I noticed the plastic bags drifting past and the other 40 guys on the boat. And so, I've gone past worrying about trying to understand that, but it's just a curiosity. I didn't have any environmental. I never had anything really. There was no environmentalists in my family. My father primed me on geopolitics and Cold War issues, but I don't know where I got an empathy for nature from. It just grew, and it just, you know. So that remains a mystery to this day, why it is that some people just so attuned to this. I mean, it might be some genetic sequence that we share.
It's a mystery, but for whatever reason, once you go down this rabbit hole and once you wake up, you will never see the world the same way again, and you can't take it back. You can't see it. Once you see it, you can't unsee it, and you are then, well, you can do anything you want with this knowledge. So, but you're going to be burdened by this knowledge. And so the people who have woken up, they're carrying a mental and an emotional burden for humanity in a way. And we feel compelled, and I'm sure you'll identify, we feel compelled to share our awakening with other people in a variety of different ways. And it takes a variety of different forms and art forms, really. And it's just almost like, did you ever watch the movie Close Encounters in 1977? And it came out. Did you ever see that movie?
Yeah.
Okay, so I want to tell you something. I'm going somewhere with this.
Yeah.
Do you recall, like, Richard Dreyfuss was making this kind of crazy mountain, and he would make it in like potatoes, and he would make it in like mud. He'd like put all his garden inside his room and make a mountain. And then the other girl was doing the same thing, and she was like making this mountain.
Yeah.
We're all, you, me, and everybody who has had this crazy awakening are making this mountain, right? We're compelled. And what I say by making this mountain, we are trying to communicate, and we are trying to share our awakening in a variety of ways with other people. And it's, for me, it's taken several different forms and art forms. And sometimes I speak and sometimes I make videos and my voice is not present, but I'm always trying to communicate. It's like a compulsion.
Yeah. And as long as you're free and able to continue doing that, it's sort of a way of having almost like it's almost it's a form of comfort. So even though you know that this thing is out there, and you know it's beyond your control to fix it, being able to communicate it and doing that effectively is at least some way. It's like a palliative almost. Like,
right. And some people that I talk to, they say, well, I mean, if there's no hope, why even bother telling anyone about it? And I get that a lot. I don't know if you ever get that. It's like, well, why are you bother telling me about it if it's that bad? And my response is always, I think humanity has a right to know, especially since it's being hidden on purpose by the powers that be. And I'm really kind of like, speak truth in this room only, right?
Yeah. I'm not. There's a very strong argument that says that we're on an inevitable slide into effectively a rerun of the Permian extinction, in which case we're gone like really soon, and most organisms will follow us. I don't believe that that's inevitable. I think it's very likely. I think that if we don't make substantive changes in the way that we relate to this planet very soon, then it will be inevitable. But I'm not yet convinced that it is inevitable. So for me, that's one of my driving motivators, is the more people that are talking about this, the more people who can then communicate it in new ways, the more people there are that can potentially be taking action to do whatever is necessary to actually fix it. So I'm not convinced we're all doomed, and therefore I don't have that question, why would you tell people if we're doomed? I don't think we're doomed. I think we're probably doomed, but it's not.
Well, one thing's for sure, whether we're doomed or not, and it's hard to say. I mean, we are it's a moving thing that's happening right now. One thing's for sure, if people are not awakened, there will be no changes. And if there's it's so corrupt at the political level, and that's really where the problems are with the corporations and the oil companies and the coal companies. They're so committed, they're making so much money, and they're in bed with all the with the political powers, really, that there's no change there. And that's where the change has to be. I mean, it's all well and good that the noble people who wake up try and do something, like I'm getting, solar panels, because I don't want to have any impact, and I drive very little and I fly very little, but that's not enough. I'm just one of 7.3 billion people on this planet. What has to change is the government. What has to change is the corporations and our dedication to to capitalism.
Yeah.
That's where the revolution has to happen. And that can only happen when people are awake and aware. So I don't really get too wrapped up on whether we're doomed or not. I'm not making a judgment on that. What I am saying is we are in a very bad situation, and we had better take a look at it. So my whole thrust is consciousness awakening at a mass consciousness level.
Yeah, yeah, great. Lovely. So, Jennifer, I would like you to share some of those slides that we were looking at before, and just walk me through contemporary issues around methane associated with the Arctic. And you're going to share your screen.
All right. So I'd like to kind of just jump into the deep end. And this is a methane map of methane concentrations, kind of like a picture snapshot. And I'm just showing this to you, first of all, so you understand that it exists. And second of all, to kind of explain how this graph works and what you can kind of see at a snapshot level. And then we'll go back and we'll take a quick look at history. So just by looking at high methane concentrations, if you look at this map, you can see that the pink, right, is the highest levels. And what you can see right away, just to I'll back up just a little bit. Gray is not measured. It doesn't mean anything. It just means that readings, the readings were not available or taken for the gray areas. White is kind of the satellite passover, and as the satellite winds and winds, you know, as the Earth is moving and the satellite is winding around, because the Earth is round, you're going to get these little white strips, and that just means the satellite did not pass over this area. So that's why it looks very strange like this, because this is taken from satellites.
Yeah, yeah.
And the red is a little bit less. So look at these concentrations that have shown up. All the concentrations that have shown up is up in the red area. And so I can tell you right now that the global atmospheric methane for Earth, present day, is around 1,850 parts per billion. So remember that number, 1850. 1850 parts per billion. And you would think, well, that doesn't really sound like very much, because it's like, how can something that's parts per billion have any effect whatsoever? But methane, to understand it, is a very volatile gas, and it is when it first comes out and it's like very strong, it's about 125 times stronger molecule for molecule than carbon dioxide is.
So this is the global warming potential, the capacity to absorb heat and hold it in the atmosphere is more than 100 times more powerful than the equivalent mass of CO2.
Absolutely. That's exactly what it means. Now, that being said, it doesn't persist and last as long as CO2, but while it's there, it can create almost like a hot flash, right? So what that means is if you have a lot of methane suddenly coming out of some deposits, right, that are somewhere, and we'll go into where those methane deposits might be, then you're going to get kind of like a hot flash, and they're seeing sudden stratospheric warming up in the Arctic especially, and you might want to talk about that as well.
So this, on this graph here, it says at the top, it says pressure 586 millibars. Now, so the higher you go up, the less the pressure is. So is this around about the level of the stratosphere? Do you know what the altitude is?
I am not entirely sure what layer that would be. I have somewhere on tap. I don't think I can lay my hands on it right now. But methane tends to kind of settle around where the jets fly. It's very comfortable right there. Right. It's very buoyant, so it kind of like finds its natural level up there in 30,000 feet.
These sudden stratospheric warmings, which is a term that's increasingly being described in this, or the phenomena that's increasingly being seen, that's associated with with methane. Is that what you're saying? That potentially pulses
Well,
methane?
it could be potentially associated with it. I don't know what if is it's associate. I mean, why it's happening, but what I can tell you is that it has been seen, especially lately in the past, like 2 years is when I've heard
Mm,
this
mm,
term,
mm,
sudden stratospheric warming. And what that means is that the temperatures at a very high altitude in the stratosphere are like 60 degrees Celsius higher than normal.
mm.
And it could be related to the methane. It could be related to a lot of things. But one thing I do know is that things are changing very, very quickly, especially up in the Arctic.
Yeah. Okay. Yeah. Okay. Great. So the grey is where there is no data. QC fail. It says there. The white is where the satellite didn't collect any data, and then all of the rest of it, which is the dark red and the sort of mauve color, represents the very high end of the scale. And it says, what was I looking at here?
Mm-hmm.
At the top left, it says range is 1554 to 2,813 parts per billion. And so just to put that
Right.
in the context, and it says in the middle, it says mean is 1830, right? And just to
Right.
put that into context, the average CO2 concentration in the atmosphere right now is around about 414 parts per million compared to 1,800 parts per billion for methane. Okay,
That's absolutely right.
good,
Yep,
thank you.
that's right.
And also this graph, sorry, was produced on the 19th of the 1st. So this is contemporaries, a couple of days ago.
This is contemporary data. This
Yeah.
graph is 4 days old. Today is the 23rd
Yeah.
of January. So there
Okay,
you
and
go.
just one more thing as well. So the higher reading, which is the mauve color, doesn't really. So if you can actually sort of, can you just point out, yeah, where Western Europe is? So what you've got there. So there's
Right. So
Scandinavia.
we can trace it. So I'm going to trace
Yes.
Europe. So this is
Spain. Yep.
Spain.
Yep.
This
Yep.
is England.
Yep.
This is
Yep.
France. And this is Scandinavia. Look at
Yep.
Scandinavia, right?
Yep.
And
Yep.
then we're getting up into the Arctic. So this is that Novaya Gagea. I can't remember how do you say that name?
Novaya
Anyways, that
Zemlya or something. Yeah. That
no,
Russian
no,
island.
the Russian island, right? So take a look here. This is what I'd really like to call
Yeah.
your attention to.
Yeah. Right.
So there are hot spots. This is the Kara Sea up here, right?
Right.
And this is this little island up in the Kara Sea. This island in particular, just FYI, is a big Russian military base, and they
Yeah.
have done so many atomic bombs
They
going
they
off
they let
there.
the Zara bomber off at the top of that island.
Yes, isn't
Yeah,
that
and so what
horrible?
I was reading the other day was they've got some guys out there doing radiation monitoring of the nuclear waste that they dumped in the ocean. And what they're finding is that there's nuclear material pouring out of that island because that island is melting. And because all those
That's
nuclear
right.
bombs.
Well, I mean, nuclear is hot by its, I mean, that's what makes it go, right? It's very
Mm,
hot.
mm,
And of course, all the radiation is heat. Everything is heat. And,
mm,
and
mm.
also, methane hydrates, we should kind of just back up a little bit. The
Yeah,
Arctic is full of methane hydrate, right?
yeah,
So methane hydrate is frozen methane. It's methane that's encased in ice cages, and that's the only thing that's stabilizing it is this little ice cage that's around the methane molecule itself. So it's a little methane molecule with an ice cage, and that keeps it tight. But it's under pressure.
mm,
And it's also susceptible to vibrations. I mean,
right,
if you shake it,
yeah,
it's going to break.
yeah, yeah, yeah,
And an atomic bomb, I can't even really imagine, like some of the biggest atomic bombs in the entire world of atomic bomb detonation have gone off on this little island right here. I can't imagine that's going to be great for the environment, right?
yeah. So the Zara bomber was the biggest one ever. That was 50 megatons. So the bomb had an explosive force of 50 million tons of TNT. And to put that into context, the bomb that blew up Hiroshima was 15,000 tons of TNT. So big bombs, and a whole bunch of them. That was the biggest by far, but a whole bunch of others.
That's
Now,
right.
so another point that I wanted to make was if you look at that graph, all of the hotspot is above in the Arctic Circle. There's below Europe and all the way down into the Antarctic, you don't see that really, really high area. So there's something going on with respect to methane in the northern part of this planet.
Well, I think you could deduce that. And also,
Mm.
it's subtle. I don't know if you can see, but down here, it's a little bit lighter color.
Yeah, yeah,
So
Taylor, yeah,
see how it says up here 1554 to 2813. That's the
yeah.
range. That means like the lowest methane concentrations in the
On the
atmosphere
graph, yes, I see. Yeah,
are
okay.
are 1554,
Yeah.
and the highest are 2813. Now, I think the
Mm.
global methane is around, it says the mean here is 1830. That
Right.
sounds about right. So I
Yeah,
think the
yeah,
global methane mean is around 1830.
yeah.
But let's keep in mind, I
Mm.
mean, prior to the Industrial Revolution, methane never went above 700 parts per billion. So it has gone up and doubled, actually. And
More than doubled, yeah.
yeah,
Yeah,
right.
yeah, yeah. Okay, so and actually you've got a graph showing that historical. Can you go to that graph?
I do. In fact, actually, you and I were having a little chat before. Now, this is a
Yeah.
little bit difficult to show, but I'm going to
Yep.
explain it. It's very
Yep.
light colored. If I
Yeah.
was going to do this graph, it would be like all colors and bold. But somebody else who's not me did this graph, because I like to make my stuff all beautiful. So I
Yeah.
don't know if you can see, guys, but
Yep.
if you
Yep.
go
Yep.
down to the lower
1,000. Yep.
left, it says 1,000 right here, right?
Year
And
1,000.
yeah, the year 1000. So this graph that we're looking at, it goes from 1000 to present day.
Yeah.
And I'm going to just trace the line because it's a little
Yeah.
bit difficult to
1,000.
see. So this is like about 700. So
600 there.
this, yeah, this is 600, this is
Yep.
800. So
Yeah.
it's right in between 6 and 700.
Yeah. Yeah. Yeah.
So it's going along. We're in year 1000. Okay,
1,200,
we're
13,
going along.
14,
We're going
15,
along. And
16.
here's Queen Elizabeth, right?
Yeah.
So
Yeah.
just
Yeah.
to kind of get you kind of
Yeah.
like it situated, then,
Mhm.
you know, here's American independence, you
Yeah.
know, for Americans
Industrial
watching this.
Revolution.
And then just check this out. So this is the Industrial Revolution. Now
Yeah.
we're up into the 1800s.
Yep. Yep.
And then we get very excited about
Mm.
coal, and we get
Yep.
very excited. First we get excited about coal, then we get excited about oil. Then, you know, then we're off to the races. But check,
And human population and rice paddies and agriculture and lots of other, lots and lots and lots more people interacting with the environment, of course.
that's right. That's
Yeah,
right.
yeah,
So take a look and you can see when we get into about, look at this. This is around the year 1900, right?
yeah,
So
yeah,
my grandparents were born around that time frame. Look what we have done in just
yeah,
since then. So in about 120 years, so
yeah,
like from
yeah,
about 1900, turn of
yeah,
the century
yeah.
to the present day, it has gone exponential. This is the meaning of the word exponential.
Yeah,
So it's gone up, 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 up. And then here you can see there's a lot of measurements because we have a lot of data. So it's a little
right,
bit bumpier.
right, yeah, yeah, yeah,
So this is it. It's getting bumpy, bumpy, bumpy. So you can see like we started really measuring it about 1980 or so. And we can do a drill down of that time period if you
yep,
wish.
yep,
All right.
yep,
So let's take a look at what has happened since 1983. We can see we were up at around 1,600 parts per billion or so around
yep,
1983.
yep,
And then we had a little bit of a hiatus. I'd like to point out that this hiatus also corresponds to the quote, global warming is no longer happening, which also corresponds to El Nino in 1988. We had such a huge El Nino that things sort of quieted down. It put so much heat in the atmosphere, and then by the time we had another El Nino, more heat came out. But
yeah,
this little quiet phase here was just a giant El Nino that, you
yeah,
know, in
yeah,
between, right?
yeah,
And my face is sort of in the way, but you can see that it's going up. Now we're almost 1,800. And this is atmospheric methane, average atmospheric methane.
Now, what
So
it says, what it says on this text here, it says methane is the second most important greenhouse gas driving man-made climate change, with some 25% of the force of CO2. So what that's saying basically is that the carbon dioxide creates more of the global warming heat, Methane comes in second, and it's around about a quarter of the total amount of heat that is trapped by the CO2, additional CO2. It's my understanding of that.
Absolutely.
An additional quarter. Yeah. Yeah.
Yeah.
Yeah. Yeah. Okay. And it's going up and up and up. And so, I mean, this is the point, right? So it's not that it's gone up and up and up and now it's flat and it's okay and it's going back down again. It's still going up.
It is.
And
it is.
the temperatures are going up. And my understanding as well is that with respect to these methane hydrates, so the methane hydrates, which is the methane trapped within the ice, is that there is a lot of it up in that northern part of the world. And B, the increased temperature that we're seeing as a result of all this extra greenhouse gas is destabilizing that methane. So the methane is potentially begetting more methane, heat begetting heat.
That's absolutely right. And then when methane comes out, it comes out quite suddenly because it will build up pressure. And if it doesn't have an immediate escape route, when it starts to melt, right? So when it goes from methane hydrate into methane, just methane, like the water melts, the ice melts, so then it's just methane. It's not encased in its cage anymore, which was keeping it under wraps, was keeping it under pressure. It actually becomes bigger. So it goes from like this big to like this big, molecule for molecule. So the ratio of how it expands, if this is 1, this is 164. So it goes up by 164 times. What that means is that there's a tremendous amount of pressure that blows, that builds up. And if it doesn't have an immediate way out, it will actually begin to lift up the land crust and form these little hills. So up in Siberia, you know, up in these little peninsulas that extend up into the Arctic, you'll see these little, they're called pingos, and they're little raised hills. Yeah. What is that? That is like the methane. So the Earth has a bad case of acne, right? And it just cannot get out. And so it just builds up into these little hills until God knows one day it finds a way out. It finds a weak spot in that very flexible biologic crust that it's been raising up, and it just blows out like that. And it creates a big flash. It's very loud. It is a huge flash. The reindeer herders up in Siberia have seen these things explode in the night in the Yamal Peninsula, and it has lit up the entire sky. And what you're left with is a massive crater. And then they're discovered by reindeer herders, generally speaking, these giant holes. And then, of course, they fill with water, and, you know, goes on and on.
I think, Paul Beckwith did a video on one of those really big, one of those holes, those ping, I don't know what the name of it is, but I think what he, if I remember correctly, what he said was, you get this buildup of methane, but because there's a lot of biological activity, it actually generates heat. And so at some point, if there's a availability of oxygen coming in and there's buildup of the methane and the heat, you've basically got the 3 corners of the fire triangle. And you get a methane explosion, which basically goes puff and throws. Now, when you actually blow up the methane like that, the methane is converted into CO2, which reduces its global warming potential. But effectively, what you're doing is you're destabilizing the whole ground. And so that's for the underground stuff. But then you've got a lot of these methane hydrates under the water. And because 93% of all of the heat from climate change has actually ended up in the ocean, it means that the water in the Arctic is getting warmer, and that warmer water is helping to release the methane. Now, I understand also that if those methane hydrates were like very deep, when they melted and the gas and the methane gas was released, if they're under deep water, then most of that methane would actually get absorbed in the ocean or actually eaten by bugs. But in the shallow parts of the is it the
East Siberian Arctic shelf.
Right. So this is very shallow. This is like 100 meters or something. And so there's a lot of this methane hydrates in the shallow water. And if that melts, then it's going to come out as gas. It's not going to get absorbed into the ocean. Is that your understanding?
That's exactly right. So the entire East Siberian Arctic shelf, it varies in depth between 100 meters and 60 meters. It's very, very, very shallow. Right. In fact, until the last ice age, this this land was actually all above water,
Right.
because
Yeah.
since the last ice age, that last ice age melt, the big melt pulse 1A, started 14,000 years ago, and it melted there was like this huge giant sea level rise, and there were three ice melting pulses,
Okay.
but all told, when you add the three together, 410 feet, and you can convert it to meters, I'm
Right.
sorry,
100.
but about 410 feet of sea level rise has already happened since the end of the last ice age. So
Right.
technically, we are interglacial still, because it melted, then it just stopped. And it just, like, the last 10,000 years is what we call civilization.
Yeah. Yeah. The whole
And
thing.
we thought that life was always like this, but in fact, it's sort of a freak long spell.
Yeah.
um, so now we're off to the races again, and we're starting up into another melt pulse. And this melt pulse will go probably uncontrollably, because now there's so much heat in the ocean and so
Yeah.
much heat in the atmosphere. And as you said, the ocean, it absorbs most of the heat, and the deposits of methane hydrate in the Arctic are non-trivial. They are quite significant, and they are large, and they are hydrates, and they are in the East Siberian Arctic Shelf, which
Mm.
means they're shallow.
Mm.
So
Mm.
what that means is we're right at the cusp where that seawater is still able to sort of maintain the cap.
Mm.
But as soon as the Arctic sea ice goes away, um, the Arctic Ocean is going to melt.
Yeah.
I
Yeah.
mean,
No,
it's going.
yeah. Okay. And so this comes back to this the blue ocean event. This idea that since about the 1990s, every year, give or take a few years, there's been less sea ice in the Arctic Ocean during the summertime. And so every
Mm-hmm.
year the amount of sea ice in the Arctic Ocean decreases, and the sea ice normally, because it's white, would reflect sunlight, and as there's less ice, it means there's more sunlight getting into the ocean, which means the ocean is hotter, which is another way that the ocean is heating up. And basically, and so this is my understanding, because I did some research on this, and it's just stunning, that the numbers. And so the amount of energy that's required to melt a gram of ice would raise a gram of water 80 degrees Celsius. And so what
That's
that means
right.
is there's a vast amount of heat, which is currently being used to melt the ice. And when there's no more ice there, then where's all that heat going to go?
Right, exactly so, Guy. And what you can do is you can think about it like this. If you take a big glass and fill it with ice cubes and put tea into it, and you have your nice glass of iced tea, and you take it out to your patio,
Mm.
that tea, as you drink it through, the next 45 minutes or so, or if you just kind of leave it, put a temperature in it, it's always going to be right around
Yeah.
that level,
Yeah.
because
Yeah.
the ice is buffering it. And as you
Yeah.
say, all the energy is going into melting those ice cubes. As soon as those ice cubes are melted, you can pick it up and drink it, and it'll already be warm, and it
Yeah.
very quickly will achieve room temperature.
Yeah, yeah. So the concern is that when we get to this sort of point sometime, and this is sometime in the next few years, by which I mean 2 to 3 or maybe 4 to 5 years, when we get down to this no summer ice left in the Arctic Ocean, there's going to be an increase. That's going to does that mean the water temperature is going to increase, which is going to put more pressure on these methane hydrates in the shallow seas, which means that they're going to start releasing more methane, which means it's going to trap more heat, and the whole cycle is just going to go up and up and up.
That is right. That is right. And they'll create these methane fountains. So there'll be like these large plumes of bubbling, and it's going to look like, carbonation on steroids, just like hugely large plumes of methane just bubbling up through the Arctic water, through that 60 meters. And it won't be absorbed. It'll go into the atmosphere. And by the way, also, when the water does absorb the methane, it turns the water acidic, and there's only a certain amount of methane that can be absorbed by the seawater. So even the water can't absorb an infinite amount of methane. It can only absorb so much, and it won't absorb anymore. And then the rest of the methane will not even try to be absorbed. It'll just go straight into the atmosphere.
Yeah, yeah. Okay. Wow, methane in the Arctic.
Lucky us.
you gotta you gotta keep a smile on your face while you talk about this stuff. Otherwise, you'd be like, "Thump."
Oh, I know. I know. It's a very dire topic. It's a very
Mm,
difficult topic to talk about. But
mm,
I think it's important for all of us to have a good understanding of what is happening on our Earth,
mm, mm.
because it will affect our life. And the only reason I say it will affect our life is because when the Arctic sea ice goes,
Mm.
abrupt climate change will set in earnest,
Yeah.
especially in the Northern Hemisphere.
Yeah, yeah, yeah. And so the destabilization of the jet stream, which allows, well, like you were saying earlier on about the finger of this little Arctic finger that's coming down, because the jet stream, which is the high altitude, very fast wind system, effectively separates the Arctic from the subarctic regions. Previously, that
That's
was
right.
relatively smooth, but now it's all kind of wavy
Right.
because it's
Well,
all falling
previously,
apart.
because the temperature delta between
Yeah,
the Arctic polar region
yeah,
and the temperate region was
yeah,
so distinct,
yeah,
the jet stream was very tight, and it had kind of like a little ruffle, and it just kept
yeah,
going around and around and
yeah,
around like
yeah,
this,
yeah,
just
yeah.
pretty consistent. Sometimes it would dip a little bit and a little
Mm,
bit,
mm,
but more or less, I mean, but now what has happened, because the temperature delta between the polar regions, the temperate regions, that temperature delta is less. So that
yeah,
means the Arctic is much warmer,
yeah.
and the jet stream is dripping. It's like an ice
Mm,
cream cone. It's
mm,
dripping. It's
mm,
dripping, and
mm,
it gets stuck. So when it gets stuck,
mm,
it cannot act the way it used to. It used to kind of go along like,
mm, mm,
and
mm.
now it's like wham, 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 right? That's the scientific term, right? But I mean, so then the weather gets stuck, and when the weather gets stuck, you can have either extremely cold, and the polar regions actually come down into the
Yeah,
temperate regions,
yeah,
which is
yeah,
what's been happening where I've been living.
yeah,
Because I live right by the Rocky Mountains, which is a natural place for the jet stream to come down and get stuck, and so we can get stuck in some really cold places,
mm, mm.
and it can be like, even I was reading the other day that over in Detroit, it was colder lately than it was in Antarctica. So, you know, that
Yeah,
means that either it's going to stay hot for a long time or cold for a long time, or, then the effect of hurricanes, as the
yeah,
temperature goes up, the effect on hurricanes is going to get, more severe, right?
yeah.
Bigger hurricanes.
Can you unshare the screen? Unshare the screen?
Absolutely.
Yeah.
Here we go. Stop share. There we go.
Okay, great. Okay, Jennifer, that's really what I wanted to cover. Just drill down into that dangerous story of methane in the Arctic. And
Yeah.
so, what I'd like to do, if I may, would be to invite you to have another conversation like this sometime in the coming weeks, where we can maybe
It,
get an
it
update.
would
So this is a really good chat because it allowed us to really map out some of the science. And so anybody who then
absolutely.
watches a subsequent one, we don't have to go back through all the science. We can just jump into
Yeah.
whatever
We can
the
we can
latest
we
news is.
can certainly do that. It would be my express pleasure to come back and talk about these important issues.
Great, great. That's excellent. Well, thank you very much for your time, and let's talk soon.
All right. Thank you so much.
Okay.